So sometimes you like to compare your data to data that are plotted in a paper. And especially in the old papers, you don't have access to the data that the authors used in their plot. Um, so it makes it a little bit more difficult to compare new data. Fortunately, CODD has a way to get around that, at least to get a look at the comparison between your data and old data. So we have an old physical properties plot here from a paper by Ed Hamilton back in the 60s, and Hamilton was one of the original phys props guys who studied properties of marine sediments. And we got porosity down here and density up here. I've actually already rotated this image to make sure that it's orthogonal before we do the registration, and there's a little video about using that rotate image function if you want to check it out. So we've got our orthogonal graph. Now we want to register it. So let's take the cursor and put it on a known spot. So in this case, it's 1.1 for density and 35 for porosity. So I'm just going to put that right there. And then I go up to CODD functions and I say register image. Okay, you get the little cursor pause for cursor panel, and we've already moved the cursor to the vertices that we want, so we'll say continue. Now it's going to enter the x value of cursor A, so the x value is 35, and the y value is 1.1. Continue. Okay, we're back again with the panel, and we'll move the cursor down, say, to the other end. There. To do that, we'll just say continue, sorry. And let's see. Still 1.1, but now it's 95. Okay. One more. Need 3 points to identify a two-dimensional object. Continue. And now, rather than 1.1, it is 2.1. That's all you need to do. Okay, now you see we've got a whoops, this guy got reversed. There we go. So you see here's a scale out here. We've got 2 and 1.5, and here we have 60 and 70 and 80. So there's our graph of Hamilton stuff. Now let's put our data on it. So we'll go to graph, pen traces. We want to go to MAD, and the y-axis is density. That's row B. And the x-axis is porosity. That's phi. And we'll do it. And there we are. And let's take these guys, turn them into markers. I like to bump up the thickness a little bit. And let's do it. Okay, so here's our data plotted on top of Hamilton's data. And we can see that a lot of the data agree with Hamilton, and then some of them have bulk densities that are kind of low for the porosities. And just for completeness sake, what I'm going to do is plot some grain densities of calcite, opal, and quartz on this plot to sort of distinguish where these guys go. So actually we can just take a quick look. Edit. So you see we've got porosity at 0, and then we have density of 2.8 for carbonate, 2.2 for opal, 2.6 for quartz, and of course at 100% porosity the densities are all 1. So that's what we're adding to this plot. And we will go to graph, pen traces. So the y waves want to be density. So that would be that guy, and X wants to be porosity. And now we can go to opal, and porosity, and quartz, and porosity. Okay, let's do it. All right, there we go. Okay, so just for completeness sake, this is calcium carbonate, and you can see that essentially these points are pretty much calcium carbonate. This is quartz, so from here to here is most of your continental detritus, and then from here to here is most of your biogenic opal. So in this site, U1553, deeper down there, in fact, were some siliceous sediments. So that's it. That's registration. It's real simple. Just pick those 3 points, and you're good to go.